So hi everyone, today I am going to discuss about chapter 13. This is the beginning of chapter 13. In chapter 12 we have learned about indefinite integrals. Today I am going to start the second step of integrals. We call it as definite integrals. So I think when we consider about integrals, definite integrals is important more than indefinite integrals. The reason is when we work in our day-to-day life as a manager or as an engineer for any industry, definite integrals are the real-world applications. So first, let's see what is the difference between definite integrals and indefinite integrals. Actually, this is a comparison between the stuff we have learned about in chapter 12 and our next section, chapter 13. So this represent indefinite integrals. We already have learned these things in chapter 12, and this is our future lesson. I mean, the lesson we are going to start today, it is definite integral. So first of all, I shall use some general problem. It is some easy one, x squared dx. So we need to integrate this one with respect to x. Now let's see, if we consider it as indefinite integral, what is the idea. So this is the idea. So already we have learned about these integrals and we have solved such problems. But when we move to definite integrals, we have to do this integral in between lower limit a, this is the lower limit, and upper limit b. So actually we have to do this integral in between some region a and b. But if we go to indefinite integral, it doesn't have any lower limit and upper limit. That is the main difference. So first you need to understand that if we consider about definite integrals, it has a lower limit and upper limit. So when in a problem you can find the difference between indefinite and definite integrals. So basically if it doesn't contain any lower limit or upper limit, it is an indefinite integral. But if it contains some lower limit and upper limit, it is a definite integral. So these are the main differences. And if we go to answers, so answer is always with a constant. So already you know, if we integrate this integral x squared dx with respect to x, answer is this one, x to the power 3 divided by 3 plus constant. But in chapter 13, if we solve this indefinite integral in the region of a b, in between our lower limit and upper limit, first we have to write the solution. I mean, already we know it is x to the power 3 divided by 3, and then we have to evaluate it in between b and a. It means first we have to plug b for this our solution, then we have to plug a for this solution, then we have to take the difference. So here you can see, if we look at the answers, in indefinite integrals answer is always with a constant, but when we move to definite integrals, answer is always a fixed value. I mean, if we plug a as 0 and b as 1, then we can get some constant answer. So it is some constant numerical value for definite integrals, but indefinite integrals, it is some arbitrary value. That is why we call this as indefinite integrals, because solution is not fixed one, but here it is a definite. That is why we call it as definite integrals. And another crucial point is, when we are learning about derivatives, we learn that it has a geometrical representation. So if we move to derivatives, we can remember that it is a slope or tangent of a graph. But what is the idea of this integral? So especially by using definite integrals, we can get some idea. uh, it has a geometrical representation. Actually, it is the area under curve. So let's move to the next slide. So if we consider this our first integral in between a and b, the idea of this integral is area under the curve y is equal to x square. So first, if we consider this is our curve, then we have to integrate, or in other words, we have to find the area under this curve in between this region. So you can see this blue colored region. So this is my lower limit a, and this is my upper limit b. So in definite integral in between a and b gives the area under curve y is x square in between a and b. So especially for our geometrical purposes, I mean when we need to find the area under curve, definitely we have used the definite integrals. So main properties and definite integrals, it must contain a lower limit and it must contain an upper limit. Then we can define it as a definite integral, and its solution must be a fixed numerical value, and it is the area under curve. So this is the idea of the indefinite integrals, definite integrals. Now let's move to fundamental theorem of calculus. Especially we use this theorem to evaluate the definite integral. So now let's go step by step. So this is the format of a definite integral. We have learned this one. This a is our lower limit and b is our upper limit. So this is the formula to evaluate a definite integral. So as our indefinite case, first find the solution for the integral. It is fx. Fx is our solution. Then second is substitute b. First substitute upper limit, then reduce by substituting lower limit a. This is the process. So mainly it has two processes. First one is this one. We need to integrate. As an example, if we need to integrate x to the power 2, we know it is x to the power 3 divided by 3. It is our fx. I mean this answer is our fx. Then plug our values a and b, and for this one plug fb in here, and then plug fa, and then take the difference. And this case has some main properties. First one is, if we need to get the summation of or difference of two functions, we can use this rule. Already we have learned this one. And second one is, if there is a constant, we can take it out of the integral sign. So previously when we are learning about indefinite integrals also, we have learned these things. So now let's go to some simple example. I think after doing this example, you can understand the idea of definite integral. So this is the problem. So you need to integrate this x square plus 2 function in between 3 and 5. In other words, you have to find the area under the curve x square plus 2 in between your lower limit is 3 and upper limit is 5. As using that rule, first distribute this integral into two parts, x square in here and 2 in here. Then integrate each one. So from the knowledge of indefinite integrals, you know it is x is to the power 3 divided by 3, and here it is x. So now this is your upper limit and this is your lower limit, and here also this is your upper limit and lower limit. Then substitute first your upper limit into here. So it is 5 to the power 3 divided by 3. Then substitute your lower limit. It is 3 to the power 3 divided by 3. then take the difference and do the same for this one. Upper limit is 5 and lower limit is 3. Here difference is 2. Then by using the numerical calculations, by using a calculator, your final answer is this one. So these are also two main properties. Especially if we change the lower limit and upper limit, I mean we change a into here and b into here, so then we have to put a negative sign in front of the integral. And also if we do the integral in between a and a, so area under this curve is 0. It means like this. So if we consider this is our curve, this is our a, so we do the same integral in between a and a again, so this area is becomes 0 because it means there is no area in here. That is the idea. Now let's look at this example. So first you need to evaluate x square in between 4 and 4. So first, as we learned before, evaluate the integral value. It is x to the power 3 divided by 3. Then your lower limit is 4 and upper limit is 4. Then plug in 4 for this upper limit and plug in 4 for this lower limit. Then you have to reduce 4 to the power 3 divided by 3 from 4 to the power 3 divided by 3, so it is 0. Actually, using the third property directly, you can say it is 0. And for the second problem, 3 times x to the power 2 dx. So if we integrate, this becomes x to the power 3 in between 4 and 2, so value is 56. And here it is negative 56. So you can see, if we change the lower limit and upper limit, here lower limit becomes upper limit becomes lower limit in here, and here lower limit becomes upper limit in here, then it becomes negative. I think these properties are used very rarely. In exam you have to do the calculations of definite integrals mainly by you are given a lower limit and you are given upper limit and you are given a function. Then you need to evaluate this one. Sometimes it may be asked as a problem of area under curve. And third one is, fifth one is, we can distribute integral like this way. I will explain. If we integrate this one in between a and b, so this is my a and this is my b, so I can distribute this region as c. So first we find this value and then we find this value, then summation, I mean total area is equal to this value. This is the main idea. As an example you can do, we need to find this integral 4 times x in between 2 and 5. So I distribute this region 2 and 5 into 2, 3 union 3, 5. I mean I find this one and this one separately. So value of the integral in between 2 and 3 is 10 and the value of the integral in between 3 and 5 is 32. So the total integral is the summation of this one, so it must be 42. Then you can integrate 4x in between 2 and 5, it becomes 42. So then we can see that our argument, that is, if we distribute the given region into two pieces, AB into AC plus CB, we can write it as a summation. So okay, thank you everyone. Let's meet on next day with